So how do you solve in general for utility maximization? You're given a utility function, the price of X and the price of Y, and some income. How do you figure out what demand's going to be, what the consumer's going to buy? So what you're doing here is you're maximizing your utility function subject to a constraint, the budget line and your income. Px times X, it's the amount you spend on X. Py times Y, the amount you spend on Y. So the amount that you spend in total can't be any more than your income. So then you can combine those into one expression called the Lagrangian. So you've got your utility function right there. The Lagrangian equals the utility function plus lambda, which is called the Lagrangian multiplier, times your constraint. The income minus the amount you spend on X minus the amount you spend on Y. Then you've got three arguments, X, Y, and lambda, and you take derivatives of your Lagrangian with respect to those to come up with your first order condition. So what's the first one here? The derivative of the Lagrangian with respect to X is equal to the marginal utility of X, your derivative of the utility function with respect to X, minus lambda times Px. That came from taking the derivative right there with respect to X, equals 0. Second thing is the exact same thing for Y. The marginal utility of Y minus lambda Py is equal to 0. Where did this come from? That came from your utility function. Where did this come from? That came from right here, taking the derivative with respect to Y. Then finally take the derivative with respect to the Lagrangian multiplier and you get your budget constraint back. What do you do from here? Well, now from here you want to combine these to start solving for stuff. So take your first two, mux minus lambda px. Go ahead and rewrite that. Mux is equal to lambda px. Take your second equation, muy, marginal utility of y, and that's going to be equal to lambda times py. And then divide those two by each other, that over that. And these lambdas here cancel out. So you get the marginal utility of X divided by the marginal utility of Y is equal to the price of X over the price of Y. And that's actually very handy because this thing right here is the marginal rate of substitution. That's the slope of the budget line. This thing right here, well, that's the slope of the budget line. I'm sorry, that's the slope of the indifference curve. That's the slope of the budget line. And what does this mean? Well, when we think about our budget line here, the slope of that again is minus px over py. Well, we're talking about tangency, our highest point we can get to, our highest indifference curve we can get to on our budget line. So from here, you would solve for, say, x as some function of y. Then you would take that to your budget constraint, right there, plug that in right there. What's that going to do? It's going to give you a budget line that depends on income, price of X, price of Y, and only Y. You've gotten X out of there. From that point, you solve for Y as a function of the prices and income. That is your demand curve for Y. Then you take this, back up, plug it in right there. So you take that, back up, plug it into where you got X as a function of Y. Now you're able to get X as a function of the price of X, the price of Y, and income. And that is your demand curve for X. Now you have your demand curve for your two items. If you need to go through and get indirect utility, go back to your utility function. Indirect utility, V as a function of the price of X, the price of Y, and income. Well, just plug in your demand curves that you've just solved for X and Y. So this is equal to the utility function evaluated at your optimal choice of X, your demand curve for X, and your optimal choice of Y, your demand curve for Y. That is your indirect utility function.